to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too long. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard before long, before it's too dark. Wake up, my love, please don't give up on me.
is up? What is up, you guys? We are back at it again. Another day here in 100 days of Rootkit. And we're about to make another game. This game's going to be a lot of fun. I don't think we're going to finish in one day, maybe 2 days, maybe 3. I don't know. We'll figure it out. Now, it's going to be really fun because throughout this whole process, we're all starting from scratch. Pretty much myself also. Why are we starting from scratch? Well, usually people will have some type of reference material, right? When they're going to teach you something, all right? Reference material is great, especially for things to go smoothly. But here, we don't care about smooth, all right? We care about authentic and real, all right? Which means that you guys will get to see the process like someone like myself will do in questioning, researching, figuring out, and then making the game, all right? So we're gonna all go through that and see and get exposed to those items together. Before we move on though, we gotta tell you a little bit about ourselves. We're Rootkit, non-profit based here in the US of A. We like giving away a lot of free stuff, including this course, which if you go to college will cost about $100,000 plus in the US of A. Elsewhere, your costs may vary, but it's just insane. Ridiculous. Come here, watch this for free. Also, if you're considering doing a boot camp, guess what? We're better than any boot camp you can do, and we're free. That's right, we're free. So you come to us and we'll teach you. Boot camps are a scam. All right, they will barely teach you anything. It is impossible to teach someone everything they need to know in a couple of weeks. All right, we're doing 3 months, and 3 months is an aggressive schedule. All right. Also, on top of all this free stuff, we like giving away free merch. So if you go over to our site and click on blog, you'll see our week 6 giveaway, and you have about 1 day left to fill this out and enter. So make sure you do that. It is completely free to enter the giveaway. You just have to do basic things like subscribe to our YouTube channel, turn this out, subscribe to our YouTube channel, follow us on Twitch, etc, etc. Now, if you do have $1 or $2 you would like to donate, you can head over here to this link. If you're watching on YouTube, it's going to be in the description, and you can donate straight to us. Also on Twitch, it's somewhere on there. It's in one of the description areas, in the about area somewhere. You can donate here, and when you donate, you can unlock certain merch, like our stickers, our awesome collab t-shirt, which I have on right now. The white color is not available. It's only available in blue. All right, this was like a pre-print version. And our epic sweater, sweater that you can get. Additionally, all donations are being matched 1 for 1, all right, for the first 10,000. So every dollar you donate, it's like donating 2. When we have epic pillars, like streaming for 24 hours straight, shaving my head live on stream, and the one no one wants to see, all right, shaving my beard. No one wants to see that, all right? This is my magic power right here, all right? We don't want to get rid of that. Additionally, if you are a Discord Premium or a Patreon member, I am the events chat in Discord right now, so you can join in chat if you prefer that instead of asking questions in the chat here on YouTube and on Twitch. Yep, Peanut Boy did donate after stream hours. I was gonna replay it live because you can do that here on this thing, but it's not showing up here on my mini feed. I don't know why, but thanks for that donation, Peanut Boy. All right. Alrighty, you guys ready to get into our next adventure here? Let's go ahead and pull up VS Code and let's make our word guessing game. This is gonna be, if you guys are familiar with Hangman, this is pretty much gonna be like Hangman, but we're gonna, as you can see the theme of the video, hang orphan, because we kill orphans in the computer science world, all right? You don't want just stray orphan processes. So let's see here. If you're not familiar with the game Hangman and you were given the request by a customer to, hey, I want you to make Hangman. Can you please make a Hangman game for me? You could do it. All right. We've learned pretty much everything you need to know in order to make a game like that. And not just the base game, but add on some extra features, which we're going to go through also, because usually there will be an original order, and then if they like what you did, there will be follow-up, maybe adjustments, add-ons, etc. that the customer may want. So we're going to simulate that too. So first thing, again, what you want to do is research. So let's go ahead and research Hangman game. So the Hangman game, for anyone that's not familiar, is literally a very brutal game where you kill someone. All right, your goal is to finish that person off, ideally without cutting all their limbs off. It's very, very brutal. All right. Basically, every time you get a guess wrong, they're gonna lose extra limbs. They're already being hung. All right, they're already dead, but you're just defiling them more often. All right. So effectively, they will give you a word, all right, like this, a word, and all you'll see at first, like this, is dashes. And your job is to keep guessing letters until you win the game, all right, or until you lose the game. And how you lose the game is all of Hangman over here's body parts get taken off. So depending on how you want to play the game, because you can give him more specific body parts, it could be 4 choices in total, so the 2 legs and the 2 arms, or you can have like feet that have to go first and then the 2 legs and 2 arms, etc, etc. You usually only get 4 tries though. You only get 4 or wrong answers, I should say. Let's see here if there are any other. A lot of people play it with different variations of the game. Let's see here. But it's up to you to choose exactly how you want to go about playing the game. That's how we're going to go about it. We're going to just give people 4 chances. And then we can balance the game afterwards based off of how difficult we want or not. Yeah, not the Orphans. Yep, I see that. Oh no, they gotta go. All right, you don't want stray processes. Worst things come when you have that, all right? Worst things come. All right, good news is this coffee is not the instant craziness one, all right? Our coffee came into the mail, so this is the normal coffee. So I'll just be my normal amount of craziness, all right? Not the cocaine addict one, all right? All right. So we know we need words. So I got us a couple starting words here to start off. You may want to create a new file. So that's all I've done here. I made a new file. I called it wordguessing.py. And now we can start creating some words. Alrighty. So we did that. I got a couple in here like process, thread, forks, and signal. All right. Just a couple words. You could do all 4 of these. You could do more. You could do less. That does not matter. That's like the first step. Well, I guess the first step was researching. Now we've researched and we figured out how to play the game. The next step is, all right, we know we need some words. So let's just get some words on this onto our page here. After that, then we got to think a little bit. The customer did not request graphics. All right, so we don't need to do graphics. We could print an actual person in the terminal and kind of mimic and make our own graphic like display, quote unquote, with text here in the terminal. I would say let's not at first, because it just adds in a little bit extra like work and complexity, when we should just focus on the core game first, and then we can add pretty pictures afterwards, because pretty pictures, they don't really do anything for your game compute wise, or sorry, not compute wise, but programmatically wise. Like the actual algorithms and stuff don't change. It's just the pretty pictures. It's the extra stuff. It's the nicety. It's what will actually get people to play and buy your game. So we're programmers, not designers, so we'll start first with the game. So when you play the game, every time you play the game, you don't know the word. All right, you don't know the word. So that means we need to randomly choose a word. we know this. We know how to do random, right? We've seen it before. So let's go ahead and do that. So just in case you forgot, to do random, that's not included in the core language. All right, it is, but it's as an extension library. All right, it's not loaded in by default. So we have to import it. So import random. All right, so we got to go grab that code and add it to our game. So we got words here, and we want to now choose a word at random. All right, choose a word at random. So how do we go about this? Well, we need to save it off. So let's just start there. So we need a word that we've chosen and in a variable. So let's call that the selected word. All right, is going to equal, well, we know it's going to equal a word in this list. So we talked about lists and strings. You can put these brackets and then choose one single word from the list. Except we want to do it randomly. All right, we want to do it randomly. So we know there's 1, 2, 3, 4 words in here, right? There's 4 words in here. So we could do, like, we could look back on our code. Which one was it? First game. And we could find this code here, copy it, bring it back over to this one, and paste it inside of these brackets because it just wants a number, and this is going to return a number to us. All right, and then we got to replace these variables because they don't exist. So with 0 and 3, because we have up to 4 guys here. All right, up to 4. So this would work. This would be fine, but there's an issue. Not really an issue. This is more like an optimization thing, a quality of life, mostly for you, because we're lazy. And, you know, if the customer later on wants like another word added to this list, or 10 more words, or to take away a word, we got to go through and we got to change this also. That's not ideal, all right? I don't want to do extra work. Come on. Aye. So what can we do instead? What can we do instead? That is a great question. What we can do instead is maybe do some Googling. All right, maybe do some Googling. All right, because we have a list of words here, and technically all we want to do is choose a random word from that list. So the way we could do that here is, as long as we know how long the list is, we can plug this number in right here. So I wonder if there's a way for us to get the length of a list in Python automatically, so we don't have to sit there counting it every time. There has to be, right? Because how would other programs work? Programs that work with hundreds of thousands of words, you know, and they tell you the word count. There's no one going in there and counting all of them. So there has to be a way to do it. So let's see in Google if there is a way to do it. So Python list count items in list. Why don't we do that? Ooh, look at that. We got a hit right here on the first one. Let me zoom in a little bit. Using the len function to get the number of elements. Interesting. Let's go and click on this link and see what is up. Alrighty. So here we go. We got our list here, and it has 4 items in the list. If we look here, elms in the list, so we're just printing that out. And then below, using len, which returns the number of elements in the list. So print, they're just doing a little print here, and they're, what is going on? God, get out of here. They're printing the len of the list. So it looks like len is another function we're learning about, and you put inside of it the list that you want to know how long it is. Very, very useful. So let's go ahead and do that here. So let's go ahead and change this to len. It's a function that we want to run, so we're going to do the parentheses, and then we're going to say words. All right, then we're going to say words inside of it. All right, It looks like it worked out. Let's do some testing. Let's see if it worked. Let's go ahead and print, and let's do selected words or selected word. All right, let's print our selected word and see if this is actually working or not. All right, so let's run it. Oh, we got a word. We got signal. Let's run it again. We got forks. We got thread. We got signal, thread, process, forks, and then we got an error. We got an error. Uh-oh. What is this error? You might have gotten this error sooner because, again, it's random. So let's just read the error and see what's going on. It says it's not happy with our random choosing of words. Specifically, it says index error. List index out of range. What does that mean? What is this gibberish that we see? Index is a term we've used before. If we go back to our singing game. If we go back to our singing game, before I guess we changed the for loop, we used enumerate. And enumerate was giving us this thing called an index. An index is the proper term for where in a list something is. All right. So anything that you put in these brackets, these curly brackets here, is going to be an index. All right. So index of 1, 0, 1. This is an index. This has an index of 0. This has an index of 1. This has an index of 2 and an index of 3. All right. The proper term is index. All right. Proper term is index. I'm saying it a lot because I don't want to have you guys asking this question over and over again after today. Index is where it is in a list. All right. Important thing. You're going to run into this issue a lot. All right. So you got to know how to solve it. So it says the list index is out of range. What does it mean by out of range? That means that we put an index in there that doesn't work, that doesn't exist. Well, what do you mean? It feels like all of the numbers would work. We got negative numbers we can put in here and it will work. If we do a -1, it works just fine. What do you mean? Well, yes, the negatives would work even if you do something like negative. I thought I would keep wrapping around. They work for a certain extent, and same thing with positives. 3 is the highest we can have, but 4 will break it. 4 will break it, and we get the exact same error when we do 4. Whoops, there we go. Exact same error. So with that knowledge, if we look back at our random int here with our len words, we can see there's a little bit of an issue here because the len of words is going to give us 4. I know there's some confusing crap going on here in the computer space. All right, we count at 0, but we don't count at 0 sometimes. Sometimes the number is inclusive, sometimes the last number is not inclusive. Look, I told you, computer programs the Wild West. Everyone's doing whatever the hell they want. All right, no one's sticking to the same program. All right, everything is going to have a variation. And why? Because that's why. All right, because they hate you. All right, everyone hates you. That's the real reason, except for me. All right, I'm gonna help you through it. So random int is one of those functions which will be inclusive for the number that you add right here, unlike some of the other functions we've talked about where it will be exclusive of that number. It will not include that number. It will include everything else but it. How do we solve this? Well, luckily for us, we can do, dare I say it, math. Oh God, math. Oh, math. We got to do math. This one's a little difficult for me, but I think we can power through it together. You guys are motivating me here, right here. All right, we know we need 1 less because we're overshooting, because len will give us the true normal human count of the list. If there's 4 items, it will tell us 4. It will not tell us 3. So we have to -1. we can do this, right? So right here at the end, let's just do a -1. Oh. Whew. Crisis averted. All right. Hey, I hope you guys all took calculus because you're going to need it. This math right here, this is why you take calculus to be a programmer, right? You can't be a programmer unless you go to take calculus. That is the one thing actually we do not teach you in this course, which colleges will teach you. They will force you to take calculus, and not just one calculus class, but multiple calculus classes in order to get your degree. We do not, because you do not need it. You do not need it one bit. Truth be told, you're actually doing calculus right now, but we'll show that off later. Don't worry. Well, we'll have your mind blown. How much calculus you're actually doing, and you don't even know. You guys have been doing it already. All right. So now with this, we know we've fixed the issue, because now if we try to rerun this a bunch, we're not running into that error. Perfect. We got our program fixed and it's working. So that's something to remember. It's very, very important that sometimes, depending on the function that you're using, you may need to do a -1 or a +1. How did I know I could do a -1 right here? You can do any type of math, anytime, pretty much anywhere in your program. All right. What can you do math-wise? That's a great question. God, so much math right now, but we gotta pump through this. So if we go over, let me close this. There we go. If we go over to our rootkit cert, let's go over actually to the rootkit site. Let's click on certs, and let's go over to Python. And let's view the requirements. At the very beginning, we have in the requirements here, we have all the basic operators that Python supports. Pretty much almost all of these ones and this one, you can pretty much use anywhere at any time. And you can guess what they do. The plus is going to do addition. The minus is going to do subtraction. The asterisk is going to do multiplication. 2 asterisks is going to do the power of, right? The power of. This will do division. This will do division and round your result, I believe. Let's go Google it and make sure I'm not getting that wrong. Of course, you're not going to help me out here. Let's see here. Okay. Well, we can test it ourselves. Let's go ahead and so this is something you can do at any time, which is very, very useful. I don't think we've really talked about it too much, so let's go ahead and introduce it right now. Python is an interpreted language. What does that mean? In real time, your code is read in and then interpreted. What does that mean? It's literally read in, and on the fly, it will go all the way down to the byte level and then be like sent to the CPU. All right. It always stays though originally, most of the time. Originally, it will always stay in human readable format, aka what you typed in. This is different than other languages like C, Golang, Rust. Those are going to be compiled languages. So you can't run them off the bat. You actually have to compile them, which will translate everything to machine code. All right. And then, and only then after it does that, you can then run that program. So for example, executables, EXEs, you guys are probably familiar with those. You can run those, but you can't read them because they're compiled. Usually they're compiled. All right. And that's like an intermediate step between running. We have never seen that because we're in Python land. If we want to run, we just click on play here and it just immediately runs. So little pro there. The other pro for interpreted languages like this is we can get an interpreter. I guess we can do it right here in this terminal. Access any terminal, just some terminal, and you can type in just Python by itself. When you type in Python by itself, You can then press enter and you'll enter the Python interpreter. This lets you run Python code immediately on the fly. So if I say something like print hello and press enter, it will run this line of code immediately. All right, it's being interpreted on the fly for you. Why is this useful? It's extremely useful if you just want to test something really quick. All right, for example, I just tried to Google, where is it? This operator. Nothing's really coming up. I'm wasting my time by Googling it because sometimes you just don't need to Google things, especially in the programming world. Just run it. See what happens. All right, just run it and see what happens. Additionally, just like there's a man page in Linux and a help page in DOS and a get help in PowerShell, there's also a help function in Python. How do you use the help function? You type in help, it's a function. So when we want to run a function, we got to do our parentheses, and then inside this we can put whatever we want to get help with. So for example, print. Now don't put the parentheses at the end of the function you want to get help with, because the parentheses are what make it execute, make it run. Just type it in normally and this will add it in a dormant state, in a non-running state. If we press enter, you'll see I get a whole help menu printed out that will tell me all about the print statement and what it does and what additional options we have. So we haven't been messing with these additional options like sep, end, file, and flush, but we'll talk about those later. So this will vary when you try to do operators, like for example the plus sign. All right, but don't worry, you don't need to do it with stuff like that. You can just type it in the terminal here. I'm going to press enter a bunch because there's not really a way to clear it. So we can just enter in raw numbers in the terminal here and it will just run them. So if I do like 5 plus 5 and press enter, you'll see it will output 10. If I do 5 asterisk asterisk 5, that will be 5 to the power of 5, and we see we get a result here. All right, so we want to figure out what's going on with the one division. So this will do a division correctly. Additionally, there's something key that happened here. It returned us not just a number, but a number with a decimal point. Whenever you see a number with a decimal point in Python, that means it's a float. It's no longer an integer. It is a float value, right? Very key distinction. You will run into errors if you try to do logic on floats when it's only handled with integers. Now, let's do 5 double divide sign and press enter. Interesting. There is no more decimal place. We got ourselves an integer, right? It's a whole number, so it's returning us a whole number. Interesting. I wonder what happens when we do division that's not clean, that's going to have a decimal point. So let's do that. Let's do 6 divided by 7. And when we do the normal division sign, you'll see we get a very long number here. And if we do 6 divided by 7 with 2 of them, you'll see we just get a 0. So the double division sign operators in Python will always give you an integer value and they'll always go to the floor. What does that mean? Go to the floor. What floor? Floor is a very fancy, very fancy technical mathematical term, all right? That only the elite use, which you are now a part of. It means it's going to round down. It's going to round down one number no matter what the decimal value is. Because you might be used to either rounding up or rounding down based off whether it's at 0.5 or not. The default behavior is it doesn't care. It's just always going to round down. Technically, it's just going to drop all the decimal points here and only have the leftover number. So that's something important to know. Let's see, there's should be, yep, percent sign is probably the only other symbol here. I guess percent sign and bang. All right, percent sign let's talk about, and then let's talk about bang real quick. So percent sign is a nice little convenience tool we have in our arsenal here too. So we can kind of see what it does if we do something like 5 divided by 2, except we're going to replace the division with a percent sign and press enter, and we get a 1. What is going on? This doesn't make any sense. How did it even get a 1? Great questions. This will give you the remainder. You remember that from, like, I don't know, first grade? Remainders. Get when you do division and then you have a remainder of something, and that was the answer you turned in. Yeah, that's what this does. This does division for you automatically, and it will just and only return the remainder. So if I divide 4 into 2, that will have no remainder. So if I press enter, you'll see it's a 0. But if I do 5 into 2, that will have a remainder of 1. All right, this is a very useful feature which we will go over in the coming weeks in our games. Specifically, it's used a lot in programming because it's very, very convenient. Specifically, where it's most commonly used is to tell whether a number is even or odd. Because if you're dividing something by 2, you now know whether it's even or odd, because all odd numbers will give a remainder of 1, and all even numbers will give a remainder of 0. So it's very, very convenient. Any questions there on the Python interpreter? And remember, at any time you guys can just drop any questions you got in. How does 5 plus 5 work in your terminal? You have to, remember, you have to pull up Python. So I guess one last thing for this, if you want to leave the Python interpreter, Control-C will not work. It handles it very elegantly. You have to do exit, the exit function, right? So you have to type an exit in the 2 parentheses. That is the only way you can exit. So remember, if you want to get into the Python interpreter, none of this will work until you're into the Python interpreter. You need to type in Python and then enter. If you're on a Linux or Mac computer, you may have to type in Python 3 instead, right? Python 3 instead. And that will get you, gosh darn it, it does not work on Windows. I don't know why. The functionality is different for the both of them. It's been like that forever. Literally could change it. It's not that difficult, but it is. Remainder was 4th grade. Yeah, one of those very early grades. Yep. Look, they taught you all the math you need to know before high school, all right? Let's be honest here. All right. Exit. So, yeah, Python 3, perfect. All right, so we learned all of those new operators, and you can use them at any time. You can use them right here inside of arrays. You can use them inside of this. You can use them on their own lines. They're very, very versatile, so remember them. So let's move forward with our game here, shall we? So we're selecting random numbers, and we fixed our little bug there, all right? So what's the next thing we gotta do? This game is just really freaking me out. There's a lot going on. Don't know how I'm gonna get through it. That's right, 1 bit at a time. All right, 1 bit at a time. We got a word. So, and we're printing the word. All right, so maybe the next step is just getting user input. Right? I don't know what we'll do with it yet, but let's just get some user input, because that should be like the next step of the game, right? Because we got the word, or maybe it should just be displaying the word as all underscores. Maybe we should just do that. Let's just do that one. That one seems a little easier, right? Let's just do that one. So let's go right here and let's do a for. Why a for loop? Good question. Should we do a for loop? Well, let's not even do a loop yet. Let's just see if we can print it out without any of the actual characters showing up. So yeah, we would have to use a for loop, right? So there's a couple ways we can go about this. A for loop would be potentially the easiest to do. So let's just do a for loop here, and let's say for each character, so char in the selected word, let's add our little but here. Let's go ahead and print an underscore. All right, and if we rerun this, look at that. We're getting there. We're doing something. All right, not much, but one bit at a time, right? So there's an issue though here. Each single line is on a new line. We don't want that. We want them all to be together, right? We want them all to be together. So how would we fix this? Have we learned anything that would fix this? Yes and no. We have and we haven't. All right. There are several different ways you could go about fixing this. One way would be, for example, let me go ahead and comment this out. One way would be, for example, so Python, let's go back to the interpreter here. Python has some interesting functionality to it, all right, which is unique to it. There aren't very many other languages that will allow you to do the same thing. All right, so a good thing to know. There's not very many other languages that will allow you to do the same thing. So if I try to add numbers together, they get added together. That makes sense, right? If I try to multiply numbers together, that just happens. That's normal math, right? Python, though, takes it a step further. They allow you to add and multiply numbers with strings, all right? What does that mean? Well, I guess you can add strings together, not with numbers. So I can add ASDF and ASDF together, and it will combine those strings together. Additionally, if I do something like A in Python, I can multiply that against the number, I don't know, 8, and it will actually make a string with 8 A's inside of it, right? This functionality is very weird. Again, it's not in a lot of languages, but it could be our potential solution here. It is one of many different solutions you can take. So if we, on this line, instead do print, and inside of the print, we do our underscore times the length of the word, right? So let's go ahead and copy this code here and paste right here the length of the word. That should work, right? So if we got to exit out of our interpreter, and if I rerun this, ooh, we got them all on one line now. All on one line. Might be a little hard to see, especially if you're a player, because it's kind of hard to see how many characters there. So we could add another space in this string, like right here, to maybe space them apart a little bit. There we go. That looks a little easier on the eyes in order to understand and see. So that is one way you can go about it. Any questions on that? I'm gonna open my window. It's kind of hot in here. There we go. Oh. Any questions on that? I don't see any questions. So let's move forward with what else you can do, or how else you can go about this. All right, how else can we go about this? Let me comment this one out and go back to our print statement here. If we hold over or hover over the print statement, we can see there's these weird additional like settings we kind of have. Not quite sure right now on how we would go about it, but what we could also do is Google. All right, a good question to Google would be Python print without new line, right? That's a good question right there. So you're not the first one to ask this question, so make sure you ask away, and we can try to see what these answers are. All right, let's see, scroll on down here. This is for avoid anything for 2.1. It will not work for you. This is what we want. So print without a new line in Python 3.x. What does X mean? It means any major version or minor version in Python 3. So it looks like they're doing print, comma, and they're setting some variable here called n to be equal to a space, it looks like. Interesting. So I'm guessing end means what's going to go to the end of the string, the end of your printed string here. And you can set it to be potentially whatever you want. This is a special variable in this function that you are able to set. By default, it has that special new character in it, the new line character in it, but you can modify it if you want. And you can actually see that here when we hover over. Does it say right here? No, it just says none. So maybe it's a built-in functionality. But regardless, we can use this. So let's run our program with the for loop again and see what happens. We get these on all new lines. That new line we want to get rid of. So if we do a comma and say end equal and parentheses, and just, I guess we'll just run it like that. That will replace the new line that goes at the end of each one of these lines, each one of these print statements. So if we rerun this again, you'll see that it's all printed on the same line now. And we go even further than that, because this again is a little hard to see. We could put a space in here, and then we could rerun it in order to get that nice spacing. Let me go and clear this and rerun it so it's a little easier for you guys to see. We get that nice spacing in here now. Awesome. This looks like it's coming along here. All right. Now, the big thing to see that we've done so far is Google. Look it up. If you don't know, go research it. Go spend time. That's a part of your job, is to look things up, to Google. You got to get really good at Googling things, at researching and figuring things out. It's a requirement. All right. It is a hard requirement. So always check things out in Google. Any questions so far? Let me check chat. Go ahead and dump any of your guys' questions. So, program's getting along here a little bit. We know we gotta get a word. We got a word. We know that we gotta print out the word in a hidden state, which we're doing right now. And we have two different ways that we know it can be done. All right, two different ways we know it can be done. We don't know which way we should really go with yet, but maybe the next thing we think about here will make it more clear. All right. Mostly it might be more ideal to maybe go with this method because we have more fine-grained control. What do I mean by that? This is always going to print everything as an underscore every single time. But this one potentially allows us, because it's a for loop, which means it's looping and looping and looping for every single character. And since it's looping and this is being ran for every single character, we can potentially manipulate any individual given character at any single time if we do some if logic in here. So I'm going to guess now with that, because we know we're going to want to change characters in the game one at a time to reveal what they've gotten right, that we're going to go ahead and remove this line. And you know what I just remembered? Hangman starts with an empty, what is the thing called? The thing that you hang people from. But you draw the person as you keep going forward and you get things wrong. So you actually kill the person when, okay. I just remembered that. So with that, we will have now, what, 1, 2, 3, 4, 5, 6 more tries? All right, 6 tries in total. Regardless if you make that mistake like I did or not, if you abstract the concept to game word guessing tries, it does not matter whether you did it as 4 and messed up like me, because as long as you make those things variables, you can just make it 6 by just putting in 6. But additionally, that's graphics, that's prettiness. Prettiness isn't a part of the core logic. If we made a word guessing game completely without knowing that little specific, it should be very easy minimalistic changes for us, because graphics always add in extra complexity and crap. All right. An empty noose, yeah, more so like the structure. I thought there was a name for the structure, but whatever. That is irrelevant. But let's move on forward here. So we now need to get input from the user. We need to track right guesses. We need to track wrong guesses. We need to display if they won or not. So let's see what we want to do first. All right. Why don't we get input from the user? All right. Let's get input from the user, and let's just start with that. All right. Let's just get input from the user. So user input equals input guess a character. All right, guess a character, because we need them to keep guessing a character. All right, and to see if this works, let's just go ahead and put a print under user input. All right, a print under user input, and let's go ahead and comment this portion out, because this might be a little, confused. I don't want to see this being printed out all the time, so we'll just comment it out. And let's rerun this. All right, guess a character. Let's give it a character, and it works. All right, I'm gonna add a little space here at the end so it looks a little nicer. There we go, and I can guess a character. Bam. All right. Except not all right, because if we rerun this again, I don't need to listen. I could put a 5, and it will take a 5. I could run this again and do a bunch of characters, and it will print out a bunch of characters. This is what you call an exploit. All right, this is what you call an exploit, and it happens all the time in software development. We need some logic to protect this game, so they aren't allowed to put in illegal characters, and they're not allowed to put in more than one character. So how do we do that? Well, we know that we're getting a string from input, right? And when we have a string can always be treated as an array. We used a function earlier to get the length of an array. That might be useful here to get the length of our string here and let us know whether or not it was valid, whether or not it was just one character. Right, we got to take it one step at a time. So let's just do character. All right, we can do length and then user input to see how long it is. So let's go ahead and just do a print len user input. All right, just to test it out. So if I run this, I'm going to do a 5, which is an invalid character, but if I press enter, it is 1 in length. All right, that's correct. If I do multiple, we're going to see now it says 7. All right, so it is properly working. It is properly working. But how do we enforce characters? Now, I've seen this, sadly, lots of times for new devs. They will not Google. They will not ask questions, and instead they will be like, too easy. I'm going to make a bunch of if statements that will track each character. So I'm going to have an if statement for an A, a B, a C, a D, an E, an F, and continue on, Please, ask questions. If it seems very difficult, at least at this stage of your programming career, if it seems overly difficult, it most likely is, and there's most likely an easier way to do it. This kind of fades off when you start getting to enterprise world, but this is very much true for entry level world. So let's go ahead and go to Google's and let's ask it something. All right, let's ask it Python. Check if a string is characters. Someone asked this question before in 2013. So let's go ahead and check this out. Interesting. It looks like there's some pre-built functionality, some pre-built functions in strings that we can use. We've seen these before, like the split one. Was it split? Join? Dot join. Looks like there might be a dot lower. Usually in Stack Overflow, the first thing that you see is the question. So this was the question that was asked, and the next post will be the top answer. It looks like we can do string.alpha. What does string.alpha mean? String is in reference to your string itself. So right here, they're making a string, and then they're doing .alpha to it. All right, that is a solution we could potentially do. What does .alpha mean? Well, let's go back here and maybe let's just do python.alpha and see, like, is this like some type of alpha characters? Like they're the top person? Are there betas too? Can we check for betas? We don't want betas in our club, only alphas. We're top dogs here, all right? So what are these ads? Okay, where's my, hold on. We gotta stop this insanity. I don't know why it's taking me this long. Where the hell is the store? Because it's on my other browser. I don't know why it's on this ad block. We're doing this live. Come here, baby. Oh yeah, I can't stand this crap anymore. It's killing me. Oh, there we go. Much better. All right, let's get rid of this crap. Hurry up. Alrighty, let's refresh. All right, much better. All right, so it looks like the .alpha method is another way of is another way you can say function. We'll get into that later. More ways to call the same thing something different. All right. So .alpha checks if all characters in the text are letters. Awesome. This looks like it will work. Now, something I'm looking for specifically, which we're not going to see unless we go to the Python docs, and how you can always get to the Python docs is say Python docs.alpha. It should be one of the first links. So right here, this is more of an advanced thing, specifically for people that are not in the US of A. All right. Not all of the solutions that you find for your characters will work if they're not English characters. All right. You need to be aware of that. If they are not English characters, the solutions will not work all the time. Let me look for .alpha. Conveniently though, you can look this up and you can also try it yourself. So is ASCII, I believe, will only do English characters. All right. There's also is alpha. This should work for all alphabetical, here we go, all alphabetical characters in the entire Unicode database that's defined as a letter. So this is a safe function for you to utilize on foreign languages also. So this will work for any language. So if you want to launch your product with multiple language support, this is something that's important to know, because remember, there's ASCII and there's Unicode. Just because Unicode's been around for 10 plus years doesn't mean that people have to support it, and a lot of things don't support it out of the box. All right. So this is something to be aware of. This is something with our own products we've come into lots of issues with, because there's a surprisingly large amount of things that do not support non-English characters. All right. So this will work again with Unicode characters that are not a part of the US. So if we do a print here and we say user input dot, again, you can see here all the functions that are built in, and you can actually see here is alnum, is alpha, is ASCII. We know we want alpha, but you should also take note, there's one for here that's decimal, digit, lower, numeric. There's a lot of stuff in here that may be useful later. All right, take note of that. Take mental note. All right, so let's do is alpha, and we want to run that. So it's going to be a dot is alpha at the end of our string. If we run this, you're going to see after we put in some characters, it's going to output true. This will output true or false. If we hover over it right here, it tells us that arrow sign there is telling you what is going to be returned to you. It says a Boolean value is going to be returned to you. What is a Boolean value? 0 or 1, true or false. All right. It's going to tell you whether that is true or whether that's false. So if we rerun this again and we do a number instead, you'll see it will say false. All right. So this is a way, whoops, messed that up. This is a way you can check on whether the character is alphanumeric or not. Any questions on there? And I don't see the point of printing the length of the user input. There is no length. There is no purpose for the actual game logic for this. It's just more so visually so we can understand what's going on. So when we do the next steps, you guys aren't going to be totally lost on why we did them. So with this, the power of using the len tool and the dot is alpha, we can start making some powerful logic here. Specifically, we can make an if statement that will require them to enter the correct characters. All right, so if we make an if statement here, we can say if the length of user input is, and we're going to have this one for if they are wrong, right? If the length of user input is greater than 1, or, what we do, or if it's that, or we can do for now just 2 if statements, so we can really kind of no, we should do definitely a compound one. If it's greater than, we definitely want to do an or. So let's do if it's greater than 1, or user input dot alpha is alpha. So this one dot is alpha will be true if it's not numeric, or sorry, if it is normal characters, which is good. We want, this if statement is for if they gave us bad stuff. So we want to do the opposite of this. Technically, we want to do the opposite of it. So how do we do the opposite of it? If this is what we want and that is good stuff, we can do a not. Not. Perfect. We can not it. Remember, not is doing the opposite. Not is doing the opposite. And we can now print here, you gave bad input. Bad person. And we can remove all of these prints here. And now we can rerun this. When we rerun this, we should see that when it is successful, it's not going to print anything. And when we're wrong, it's going to give us an error. So if we do a G and press enter, nothing gets printed out. That's good. If we do something like 2 G's and press enter, it said that we gave it bad input and that we're a bad person. And now if we give it a 1, it does the same thing. So it looks like our logic here is sound. It looks like it's protecting our game, and it's identifying when when they've entered bad stuff. Right? Makes sense? Any questions on that? We wouldn't do an and here Because and requires both of them to be true in order for this to execute. Well, they might have entered a longer amount of characters, but they may just be all like normal characters, not including numbers. So this would be false because they would have entered normal good characters, but it would have been too long. And with an and, this would not execute. So that's why we do an or, because or will execute even if only one of these sides are true. If one side of one of these sides are true, it will execute. If both of the sides are true, it will execute. So we're getting as much possible coverage there is. Can you put and plus and or? Yes. You can tag along as many ors and ands as you want, but you cannot have them next to each other. They have to be different combining logic. So I can do an and here and say and true. And you can put whatever logic you want here. Additionally, if you want to force it to compute certain things before others, you can always use extra parentheses. The parentheses you can add anywhere at any time in order to force whatever's inside of it to execute first, because it works just like math. From your math classes, parentheses always get executed first. For example, 2 true statements and 1 false. Or you just limit. Nope, you can definitely do that. You can definitely do you can definitely do an or and then an and right here and have another and, like user input dot, I don't know, whatever you want. Maybe you want to filter for capitalizations. All right, you could definitely do something like that and run it. And now it will only let us do lowercase numbers. So if I do a lowercase g, it will be fine. And now if I do a capitalized G, it's going to, sorry, this is anded together. So this needs to be going off and this needs to be going off at the same time. So I need to have a capital letter and a number in order to get this stuff to go off. Because remember, this is an and between this and this. All right. This and this are not being evaluated. It's only this, because ands are a little join operation. If we wanted to make this a little bit more clear, the default behavior is going to kind of look like this. This is why parentheses can be your friend, so you can force things to happen beforehand. But let's go and rerun this and do a capital G. Whoops. Capital G and a 1, and now that will not go error out, but it was already doing that before with our logic. So it would be better to have an or right here, because if we do an or right here, and now we just do a capital G, it won't let us run with a capital G. It will only let us run with a doesn't like it with a normal G now. Also, I'm guessing, does that have to do something with our or here? I'm not going to dive into it anymore. The main point is you can string together these as much as you want. The typical format when you're having a lot of these, because sometimes it can go for a really long time. You don't want to be scrolling sideways for a long time. So typically people will just enter them onto their new line, onto a new line, and then move forward from there. I believe this is the format for it. So that way it looks a little bit cleaner. We're not going to go into that too much right now, but that is something you can do, so you guys are aware of it. Let me go and undo all this and remove this capitalization because I don't want that. There we go. We're back to where we were. All right. Let's go ahead and go on a break for like 3 to 5 minutes, and we'll be back after that. If you have any questions, go ahead and drop them in the chat, ask away, and we'll answer them right when we get back, and then we'll continue forward with our game here. All right, I'll see you guys in 3 to 5 minutes. All right. We are back. Before we get into it, just so you guys know, we are Rootkit, a nonprofit here in the US of A. We like doing a lot of stuff for free. So while you're watching, make sure you go over to our site, click on blog, and enter the week 6 giveaway so you can win a sweater. Additionally, if you guys are chatting away in chat, we are watching and logging. So that way we can do some surprise giveaways to people who are participating in the live sessions. Should we include... We'll test this out. For all those people that aren't in the live sessions and watching the YouTube videos afterwards, if you leave a comment, then we'll add you to the pool. All right, we'll add you to the pool. We'll see how this goes. All right, depending on how that goes, we'll continue that. Additionally, if you like what we're doing and you want to help us out, because doing things for free is not cheap. It's very, very expensive. You can go over to this site, which is in the description of the YouTube video and on our Twitch page, and you can donate to us. Everything you donate is tax deductible, so avoid those taxes, all right? Avoid those taxes. Depending on how much you donate, you can unlock certain perks, like our stickers. You can get one of these awesome collab t-shirts. They're only available in blue. This is a pre-print shirt, and our awesome sweater. All right, all donations for the first 10,000 are being matched 1-for-1, and we have a bunch of goals that we're hitting along the way, like streaming for 24 hours straight, shaving my head here live on stream, and most likely not going to shave my beard here on stream because we don't want to get there. No one wants to see that. All right. Alrighty. Before we move forward, I'm gonna go on a quick thing for you guys. We just posted in the dev news on our site this article that God, get out of here. God, of course. Now that I have this, I'm gonna get all this stuff once. Refresh. Article here. In regards to cyber attacks, hacking. The most common types of hacks are just straight up phishing attacks, aka social engineering. Social engineering is the most common type of cyber exploit. It happens 24/7 to everywhere. This specifically, we talked about it before, would not be any phishing campaign. This would be a spear phishing campaign because it was specifically targeting people at Reddit, developers at Reddit. What were they trying to do? They made a fake website that looked like one of their internal websites. All right, it looked like one of their internal websites. You can see right here, landing page impersonating its intranet site. What does intranet site mean? Intranet means within the company. All right, within the company. So they made a fake site that the internal insides of the company uses in order to steal the employees' credentials. All right. Now, this could also become more buzzy. It depends on how the reporters feel at the time, but they could have said the deep web. All right, because technically intranet sites are a part of the deep web. All right, the deep web is, you've used it before. Also, again, in computer science world, no one can really agree, or it seems like no one can agree on terms. If you ask experienced senior devs, they'll tell you what it is, and they'll all agree on what I'm about to tell you guys. But news outlets, they don't know anything about computer science, so they will change their mind on what means what. The best example is for AI. That's just thrown all around for anything. So they pretty much made the definition of AI very general. So AI is what you can be, it can be used for things that are advanced, like GPT, which a lot of you guys have probably heard of that, all the way down to the AI in Pong, the original Pong. All right, that's technically an AI too. All right, which one's more impressive? There's a big difference between those, but that's a subject for another day. So depending on which graphic you look at, they'll tell you different things about the normal web, deep web, and dark web. The deep web is actually also incorporates websites like Facebook, Google, and etc., etc. Why? Because their sites, any site that is hidden, they have pages that are hidden from normal viewing on the internet, is going to be a part of the deep web. So if you're logged into Facebook and you're viewing your mom's Facebook account, if her Facebook account is set to private or like friends only and it's not public, that's a part of the deep web now. Additionally, all internal websites for a company are technically deep web. One of these pictures have it well. Things like medical documents, financial records, etc., like your bank information, your banking account, you have to log into that, right? That's not public. That's the deep web. So a lot of times people will throw around deep web because it seems cooler. It's just normal internet. It's what you think of it. All right. All right. Side tangent over. Let's go ahead and move on here. So let us see here. Our game. So we're doing proper validation now on our input. It's all good now. Sweet. So we can take the next step forward. This is only happening once. So we want to run this more than once. Also, we can do that with a loop. But the question now is, what type of loop do we need to use? A while or a for loop? Well, we do know that the game technically won't run forever. It will only run for up to the max amount of guesses they're allowed. So you could make an argument that a for loop would work. And you wouldn't be wrong, you could do it technically with the for loop. I'm going to go with a while loop though, because a for loop usually you use because you know how long it's going to run for. It's going to run for that entire time. While loop, on the other hand, is when you don't know how long things are going to run for, in the sense that we don't know whether they'll finish the game early or not. So I think we'll do a while loop here. Mostly, the other thing why I think a while loop would be better, because in the while loop logic, we can make the game automatically stop when they win. All right, we can't do that with the for loop. So that's another nice perk of the while loop. But again, like I said, you could technically also do this with for loop. It would get a little more sloppier, and the best way would be using the while loop. All right, specifically, it would get sloppier if you for a for loop is if they enter in the wrong character, you're going to have to start the loop all over again because you need them to enter another character. And if you're only looping for 6 times period with the for loop, that's going to mess everything up. So you would need to add more logic, and it just gets a whole mess. So while loop is going to be your best bet. Rule of thumb is anything with games, most likely a while loop would be best. So we want to keep looping this until they win the game. We haven't really made the winning logic yet. So as a placeholder, we're just going to put true in here. We're going to make it loop forever. We know how to stop it, so we'll stop it manually, but we'll make it loop forever. And this is okay because we have user input we need to collect, which will forcefully pause the loop until we enter input. So we won't get that infinite loop craziness like we had before. So let's go ahead and tab all of this up, this logic right here, because we want this a part of our loop. So we got to tab it up and put it inside of the while block. If we run this now, you see it will run and pause at the input. We can enter in some input, press enter, and bam, it will loop back. And it will just keep doing this forever. All right, perfect. If we want to stop, we'll do Control C, and there we go. We've exited the game. So we'll keep it like that for now. So we've now upped our game. So now it's running and running and running. We know we need to put some logic in for winning, but we just started on the character stuff, so maybe we should finish this up. Specifically, they're guessing a character, and we need to print, the word. So let's go ahead and uncomment this part here that we commented earlier, and fix that correction right here. Add that back in. So now we'll see every time the game loops, it will print out our word here. This looks a little bit weird. Why does it look weird? Because remember, we replaced the ending with the spaces. So there's a space right here, not a new line. All right, there's an easy way to fix this. Don't worry. But before we do that, I think it would look nicer if so for example, if we restart this game, if you look, if we click play, it asks us to guess a character before we can even see the word. So ordering here is kind of important. So we want to put this for loop up here at the beginning before we get the user's input, because we want to see what word we have to guess first before we have to guess a letter. So if we do this here, let's go ahead and rerun it, and you'll see it's better now, but we don't have this line on a new line. Or maybe you like this layout. I don't know. It's your personal preference. I don't. I want this on a new line. Because we're altering the ending here, that means we need to fix this. We need to add our own new line. There's two ways you can go about doing this. One would be after the for loop here, you can just do a print with nothing in it. This will just print a new line. All right, if we rerun this, you'll see it just prints a new line because we didn't add any custom logic, and we now know with our knowledge of print and this end thing has a new line in it by default. So it will just automatically put in a new line here. The other alternative we have is, if you don't want to do it this way, you could just put at the beginning of this line right here, you could just add this new line special character. And if we rerun this, you'll see that close this and rerun it. You'll see that that works also. Both are correct and both work just fine. I'm going to personally do it like this because here I can just easily see the whole block of logic for printing out the character, but you can do either or. So let's see, any other questions? What's up, Dabber? So this can be applied by making 3 rows of characters in a tuple and making tic-tac-toe. I found out. How are you all doing? What did I miss? We're making Hangman right now. Yeah, you can do this exactly for other types of games like tic-tac-toe. It's extremely useful. All right. So we're taking little steps forward here, like I told you guys, one bit at a time. So let's just do a review. We got our words. We're randomly choosing a word every single time. So our game is random. We're printing out the word, but with all underscores. All right, so it's a mystery. And now we're accepting input from the user. Awesome, we're getting there. Now we need to actually do something with the user's input. Now, this can be done multiple different ways. All right, multiple different ways you can execute on this. I think, so if we think about it, you can be creative with your solutions. I would say maybe people by default would say, you want to try to recreate the word that was selected in a new variable, that would work just fine too. I think what will work better, or how I would go about it, is maybe using a mask. A mask? Where do masks come in? What are masks? We haven't learned about masks. What are you even talking about? Masks, they're not complicated. They're just like what you would think, like a mask that you put on your face. That's the type of mask I'm talking about. Masks are a common term that you can find not just in programming, but in video editing and photo editing. Masks are what a lot of people on Twitch and so forth will use in order to help them green screen stuff. I don't technically use a mask per se for mine, but that is something you can do. If we look up a mask, this will probably not result what we want here. So the key thing here for the mask is actually masks in real life will cover things up, but you can be selective. You can cover your whole face except for your eyes. You could cover your whole face, including your eyes. You could cover just your mouth. You could go forth with this one and just cover everything except for your mouth. The point is, a mask can cover, but you choose what it covers and what it doesn't cover. That's the key thing, what it does and doesn't cover. Let's look at video masks. So these aren't great examples. Video masking. Let's do photo masking. I'm looking for a there we go. So this is kind of like a mask right here. This outline of her, you can see one part is white and one part is black. All right, the white parts are what's going to not be transparent, and the black parts are going to be transparent in this photo, for example. What's another? Come on, you gotta give me more. There we go. So you have, if you had a square box with this nice little pretty gradient, let me open this image in a new tab. A square box with this pretty gradient, and you wanted to put a mask on it. So we got black here. Black means it won't shine through. White means it will shine through. Kind of think of it like you have a piece of paper and you can cut holes in that paper. The black parts will be the paper. The white parts will be what you can see because you cut that hole out of the paper. If we were to put this mask on top of this picture right here, we'll see this masked object here on the side. All right, we'll only see what the mask will allow you to see. This can be very, very useful, especially in computer programming. Now, the key thing, you might ask, okay, cool, how the hell do we do this? Am I gonna have to like pull out all the bells and whistles, just go to the extreme? No, there's a key thing here, specifically in the mask. The mask is a binary system. What does that mean? Things are black or they are white. There's only two options. You know what else is only two options? Zeros and ones. There's only two options. What do zeros and ones also mean? Trues or falses. All right, they're all the same thing. And guess what? For a game, you can only have a character guess correctly or not have a character guess correctly. The character will show or it will not show. It's all a binary system. So masks could work really, really well for us. So let's go ahead and go take a look at this. Again, this is one way you could solve this problem. This is not the only way you could go about solving it, but this is the way that we're going to go about it. All right, so let me check chat to see if is that kind of how a green screen works. Yes, that is technically how a green screen works. So you can select what color, for example, green, and that will be masked out. In film production, it's more and more common to see blue screens used instead, so they will mask out blue. And the YouTube chat is popping off. My God, you guys typed a lot. I'll check this in a second because I want us to get through this mask part here first. So we know we need a mask. So let's go ahead and say mask equals, what does mask equal? Well, we want a mask, and the mask needs to cover the entire word. All right, cover the entire word, which means this needs to be as long as the word is. So how we can do this is two ways. I'm going to show you guys the long format way that we've already seen, and then I'm going to show you the shorthand format. All right, how you could do this is you can make a empty mask, and we can do a for loop. So for char in selected word. So let's loop over every character in the selected word, and then on our mask there is a special action you can take on arrays. If we do a dot, you can see it here. There's something called an append. Append is how you can add things to an array. All right, how you can add things to an array. So let's append for every character. Let's append something to our mask. We know masks are typically Boolean systems. So let's just go ahead and do a false. What this mask is for is it's going to be false if they have not got that character, and it's going to be true if they have guessed that character correctly. So if we do this, and let's go ahead and print our mask here so we can see what's created. And remember, we have that exit function. So let's just exit right here so we don't have all this stuff below running. Let's see what's going on here. Cancel this program, clear, and run. You can see that we have, at first we have a blank array. If we do a for loop, this for loop will only loop for every character in the word. All right, because strings again can be treated just like arrays. So we're gonna go over every character in the string. Every time we loop once for a character, instead of doing logic with this character, we're going to ignore it completely, and instead we're going to add a false to our array here. All right, and now we have an array full of falses. All right, full of falses. Any questions on that? I don't see any questions in regards to that. So this is one way you can do it. The other way you can go about it, which is more of an advanced way, this works just fine. Yeah, go ahead. You can fix your code. We're not moving on yet. I'm just going to show a different way to generate the mask using a for loop. All right. So I'm just going to keep this right here below. So another way, let me go ahead and comment this out. You could do this is using a special thing in Python for shorthand. All right. What does that mean? Let me go ahead and type it out, and then I'll explain it afterwards. False. There we go. My terminal just keeps printing you gave bad input. I put an exit right here, so make sure you do a exit. Also, for Booleans in Python, you need to capitalize the first letter. So true needs to be a capital T, and false should be a capital F. So this is a shorthand way of doing what I did here below. They are the same. They will produce the same output. I believe this in the underlying code is faster, technically faster at compute time, but for our game it doesn't really matter too much. This can be more clean, or it could be more confusing. Shorthand is totally up to you whether you want to use it or not. If I run this right now, you'll see we get the same array produced. It's exactly the same. What is going on here? So this is our normal for loop right here. And effectively what's in front of it is what's going to be added to our array every time this loop happens. So we're adding a false every time this loop happens. All right. This is the shorthand. You guys can Google and research and check it out more, but I just want to show you guys this is the shorthand, and this is a way you can go about doing it. All right, I'm going to comment this one, and I'm going to keep the longer version in here because the longer version makes a little bit more sense, and it's not as like difficult to kind of understand. Alrighty. Let's see here. All right. If we rerun this, you'll see we're back at the normal array. So let's see, bad input, paste the error in chat. Any errors that you're getting, put them in the 100 days of rootkit, the rootkit channel inside of Discord, so we can see the error in its entirety. So we know we're making a mask now, and the mask is how we want to dictate what gets shown on the terminal or not. All right, what gets shown on the terminal or not. So that means we need to now change. The next step would be to change our logic here. All right, our printing logic. Because right now our printing logic will always just print underscores. Always. There's nothing that's controlling it. We made a mechanism in order to control it now. So we know that if the corresponding item in our mask array to the corresponding string is false, we want to print an underscore. Let me bring up Paint here just to make it very, very clear on what's about to happen. Let's say we have the word hello. What's a shorter word? Hope. Let's say we have the word hope. All right. Each one of these are going to be, index of 1 or 0, 1, 2, and 3. We have, and this is our selected word, all right? Our selected word variable, our selected word. I'm going to do SW. Selected word variable. We just made a new variable called mask, all right? This is going to have inside of it, by default, false, 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 and false, all right? And they are now, we're going to make logic to keep them linked up, all right? To make it so when we print this, every time it shows as false, it's just going to do an underscore for that corresponding letter. If at any times any of these turn into trues per se, then instead of doing an underscore here, we're going to print out an O, all right? So from looking at this, we know that our logic has to be something around the realm of if the character and the mask for that character is false, print an underscore. If it's true, print the actual original character, right? So if it's false, print the underscore. If it's true, print the actual character. So let's go in our for loop here for our printing, and let's enter in a new line. And we know if, so this is where something like enumerate might come into handy again, because if we do if mask, which item in the mask? How do we get that item out of the mask? Well, enumerate can solve this for us. So that way we know which item or which character we're on. So before moving on further, we're going to need to put enumerate around the selected word, right? Enumerate, we know, will give us the index and the character. So we can go now here to the for loop and make a new variable called index. And now we have the index in the character. So now if we do our if statement here, if mask brackets the index, all right, so now we know we're synced up, equals false. All right, this is a little extensive and I'll show why here in a second. But if it equals false, then we want to print an underscore, right? We want to print an underscore. Let's just test this out first, all right? So if we run this, everything is false by default. So this should just be doing the same thing as we had before, printing underscores, right? Let's go and run this. It looks like we're good. It looks like we're okay. We can also test this to see, right now we don't have any logic on whether it's true. and what to do with true stuff. So if we change the false here for what we're adding to the mask to a true, we technically shouldn't see anything print out because we don't have any logic for that. So let's go and run it and see what happens. Whoops, I gotta cancel the program, clear, and run this. And we don't see anything print out because we don't have any logic here for true. So let's go ahead and add some logic here for true. We can copy this whole thing, paste it. We could say elif. The pro gamer move would be to do something more like an else, because there's only true or false. All right, it can never be anything else. So if it's anything else but false, then do this. Well, we know we don't want to print an underscore. We want to print the character. So instead, let's just remove this and just say print the character. Except we do still need this end part because we don't want it to print the new line. So we'll do char and then end. So now if we run this, I clear it. Now if we run this, you'll see we get our word prints out here. That's awesome. Why is the word printing out? Because we have our mask all set to true right now. So let's go ahead and remove that and clear, and let's change this back to false, and let's see if the whole word is hidden. Look at that. The whole entire word is hidden now. That's pretty neat. That's pretty nifty. All right. We have some working logic here. Now there's some changes we'll make to it here in a second to make it more correct. But before we get into that, are there any questions right now? Lots of chat in the chat here. It's running out bad input. Make sure when you're rerunning this, since it is an infinite loop, you have to, because right now it's running. So if I make a change in my code and if I click the play button again, you'll see it says I gave bad input. This isn't actually going to stop your program. So you need to go in here and press Control C in order to forcefully stop it before you click play again. All right, before you click play again, or else things are not going to work correctly. You have to forcefully stop it. Let's see here. If else syntax function, confused with this earlier. Our day earlier, we had an earlier day for if logic, so you can go back and check that one out. Control C for Mac is going to be command. So anytime I say control for Windows and Linux users, most of the time it's going to be the command key or the Apple key. All right. The command key has that Mac command key. It has this symbol right here, this thing on it. All right, I see your code here. That's my code, and this is the indentation error. Not sure where the issue is though. You got to send me your error, the entire error. You have to look to solve errors. So for example, an indentation error. I mean, mine I don't think will even run. Yeah, it will run. To solve the indentation error, you need to look at the entire error, because at the very beginning, it will tell you a line number, and also at the end here, it will also tell you a line number. So looking at these line numbers are different. Not all the time will it be very clear. So you're gonna need to look around and figure out which line number it is. And then you can go about solving it that way. So the one adjustment we would want to make here for if statements. If statements will always just compile down and evaluate a true or a false at the end of the day. All of the fancy terminology that you put in here, for example, like this, if isn't going to touch that. It's not going to mess with it all. Before if even looks at it, this stuff that I have highlighted right now will be evaluated and turned into a single binary value, a single true or false. All right. What does that mean for us up here? For us up here, that means that we don't need to do equals to false, because we are only passing in a single binary value. So we can just remove this because we are already giving it a true or a false, what it needs to do the final evaluation. So we can just do that instead. All right. Now this will also change our logic a little bit, because this will only run if true. All right. Remember, ifs don't run if something is false or fake. All right. It only runs for the truth. So that means we need to now switch our print statements around, because before we had equal false, but without this one is going to run now for if it's true, and this one's going to be false. So that's a quick fix. We can just grab this one and paste it up here, and grab this one and delete it, and then paste it down here. Switch, we'll do a little switcheroony, and now we have it in a more proper state. So it says there on line 20 is your error. So check line 20 for your print, and it's going to be an indentation error. So I can, the easiest way to try to fix that is backspace the indent and then press tab again. So for example, if I was getting one right here, back and then press tab. Additionally, if you hover over this indent right here, this is kind of the annoying part of Python. Indents on this editor by default are going to be actually 4 spaces, and when you press tab, it will actually enter in 4 spaces. Spaces are different characters than tabs. Again, tabs are special characters. If we do /t, that will give us a special tab character. Those are completely different than spaces. So if you have a mix of tabs and spaces in your Python code, it will error out and give you indentation errors. So make sure those are correct. If you hover over your spacing here in VS Code, you will see little dots. The dots means you have spaces. Python will run with spaces and with tabs. The only thing that matters is that you're consistent. All right, if you're using tabs, use tabs everywhere. If you're using spaces, use spaces everywhere. VS Code by default should handle all of this for you. Can I scroll down a bit? Yeah, let me pull this down a little bit. There you go. This is all the code right here. So this, I think, is going to be all that we're going to cover today. We got pretty far through this program. As a recap, we have, I'm going to remove that space there. We have a word list here. So our customer came to us and they said, hey, I want you to make an application that will be a guessing game. All right, a guessing game for words. All right, I'm going to give you a list of words, and then I want you to make a game so users can attempt to guess the words, and they only get a couple of tries, and when they're out of tries, the game's over. And if they guess the word before the tries are over, then end the game. I was using combo spaces and tabs. Yep, that's definitely going to be the issue then. You got to use one or the other, not both. So with that knowledge from the customer, you started on your program. We put in a list of words here, all right, that the customer gave us originally on what they want for their program. Now, with this words, we know to make this game fun and interesting, we don't want to make it predictive. We want to make it a little random. So on this line, we're going to be randomly choosing a word using this cool random int function that we learned about the other day. 0 is where to start, this is where to end and randomly choose a number between these. And we have to do a -1 because len, we learned today, len will count and tell us how long an array is, or sorry, a list is, and a string. All right, that's super useful, except it will tell us in normal human terms, not in computer terms. What does that mean? It's going to tell us this is a length of 4 when a computer sees this as 0 through 3. So we have to do a -1 at the end of it so we can convert it back to human terms. All right. All right. After that, we have our selected random word. Now we know that we're going to use the mask method in order to be printing out the characters that they need to guess or that they've already guessed correctly. All right, we're going to be using the masked method. There are many different ways you can go about this. This is just the one we're doing. So we're making a mask, and at first it's going to be completely blank because we don't know how long the word they selected is. All right, so we need to dynamically allocate how many items we need in the array. All right, some fancy language so you can sound super cool about what you did here. All right, you're just making this a dynamic list, which means it grows in size based off what the word is. So we use a for loop because for loops are what we use when we know how long something is going to be. We say char in selected word. So for every character in our selected word, because strings at the end of the day will be treated like lists. We're not going to do anything with char. This is just the format we have to supply. So we'll just supply this format, and then in here we're going to take our list, and we learned there's a bunch of pre-built functions in lists. So looking through them, masks dot, we can see a bunch here. And I revealed that append is the one that you guys need to use. And inside of append, you just put the data that you want to add to the list. All right. So this is going to add a false for every single character in the word. Now you can also figure this out if you Googled it. If you Googled how to add things to a list in Python, that will give you the exact same result. It will show you .append. Excuse me. After that, our game has begun. Our game right now will go forever. We don't have any logic to make it stop. That's okay though. We can just use Control-C for now to forcefully make it stop. For making things pretty in our game, we have our printing happening here first for our word. It looks kind of complicated at first, but don't worry, it isn't that complicated. We'll explain it. Additionally, this is why comments are really great. If you're finding yourself forgetting things or not remembering what something does, add more comments to your code. All right, it should look, especially early on, like a whole ass novel. All right, if we go here, it should look like a whole ass novel. All right, so you can memorize these if you're finding yourself forgetting what everything is doing. So in this, we know we want to print an underscore for every character that they need to guess. So that's going to be another for loop, literally just like this one on line 9. We want another for loop just like this one. Except we want to also incorporate our mask logic, which requires us to know which character we are in, aka which index of each character we are at right now. So we need to get the indexes of everything so we can keep our lists synced up. So we know if we use this enumerate function, it will give us the index, so we can use that. So that's why we're putting enumerate around selected word, so we can get the index and the character. Inside of our for loop, we have two things we could be printing: the underscore or the character. One or the other, the underscore or the character. So we have two logic blocks in here, one for an if and one for an else. The if is going to run if it's true. So anytime the mask is true for a single index, so this is where the index comes in handy to keep this mask list and the selected word in sync. So if this is true, then we're going to print the character. And we have this little funky end thing here. All right, it's called end. You have to call this end because this is a pre-made thing in here called end. Right, it's a pre-made little variable you can assign called end in here. This will make it so we don't see a new line. All right, so everything will print on the same line. And then if for anything else, so if it's a false, if it's a number, if it's a string for some reason, we don't care. For any other reason besides it being true, we're going to run our else block, which will print a underscore instead. All right, we'll print an underscore instead. And then we're going to do a little print at the end of our for loop here. So this whole block is going to run. When it ends, we're going to do one more print because we just need to have a little new line show up. So that way our user input here doesn't show up on the same line. So the next thing we're doing is we're getting user input, and we put a little prompt here. You can use whatever prompt you want or no prompt. That's totally up to you. We're storing user input off. And after that, we're then doing a little bit of logic here. We have a custom algorithm we've designed here. Very sophisticated. All right, very sophisticated algorithm we made from scratch. All this is a little if statement that will get the length of what they typed. And we want to make sure whatever they typed is less than one character, or sorry, is one character long. This is actually will bug out, so we got to fix this one also. It can't be more than one character long. It cannot be more than one character long, or else it will throw an error. Additionally, if they do give us only one character or more characters, we'll still throw an error. But if that one character is not an alphabetical character, if it's not an alphabetical character, we'll throw an error too. All right, we'll throw an error also. So this is just some validation. There is one bug I found right now by reading this out loud. This, as long as they give us something that is less than, all right, less than or equal to 1, less than or equal to 1, this will run. Which means if we don't give anything, oh, never mind, we're saved. If we do give it nothing, which would technically fulfill this, it technically nothing is not an alphabet numeric character, so we're saved. Never mind. There is no bug. We're good. I thought there would be a bug for a second. So that is everything we've accomplished so far. What questions do you guys have right now? It's saying that because you're not ending your program. Like I've said before twice now, when you are running things, it's in a while loop. It's going to run forever. It does not end. So if I click and try to run this again, it's trying to put this command on top of this running program, and it's not going to work. So you need to stop this running program. How you can stop it is pressing Control-C. You need to stop your program first and then click the play button to run it again, and then it will work. You need to stop the program first. What other questions do you guys have? Before I give the challenge. Get out of here, Kote. I think it's very convenient, all right? Using white spaces over the other option, which is curly brackets everywhere, because that's extra typing, all right? I gotta type things, more characters to press. Command-C isn't working. I've pressed it into oblivion. Then try Control-C. On Macs, they also have a control key. So try that also, because it's... Macs are a little weird. Sometimes it's Command-C, Sometimes it's Control C. So press Control C instead. There is a control key on your keyboard. Grab mine right here. Oh, let me open this. Right here. Where's my camera? Right there. The control key says control. Click that. It also has that icon right there. So click that one. That should work. If that doesn't work, then I guess you're just gonna have to close the terminal and then rerun it. All right, perfect. That worked. Great. Good. Hey, Macs are weird. All right, they're a little funky sometimes. Let's see. I was just about to start punching through my screen out of frustration. That's all right. You'll do it eventually. You should break at least like 5 monitors before you get your first computer programming job. All right. Going through monitors is like a normal, thing in tech. All right. That or smashing your keyboard or smashing your mouse. It's best just to keep all baseball bats away. All right. Keep them all far away from you so you don't accidentally just grab it and destroy things. So I don't see any other questions coming in on what we've done so far. So challenges. We got 2 for you. Number 1, put comments everywhere. Add comments to your code so you know what's going on. So it makes sense. If you are a Discord Premium or a Patreon member, I'll be sending you this code with lots and lots of comments and documentation, so you can just view those. This second challenge is I want you guys to now add the logic for guessing. You can keep the game going forever. You don't need to track tries if you don't want to. But right here at the end, we know we've gotten good user input. That's going to be a single character. So add logic here to change the mask based off whether they got the characters right or not, right? Change the mask based off the characters they got right or not. Your hints are you're going to need a for loop and you're going to need an if statement. Or 2. Or 3. Or who knows. I won't tell you how many if statements or for loops you will or will not need, but you will need at least 1 for loop and at least 1 if. You may get away with just doing it with 1 for loop or 1 if, or you may need multiple of each. Who knows? That's for you to figure out. That's the only hint you guys will get. That's the goal. Go ahead and try to complete that. Send into the 100 Days of Rootkit Discord chat if you got it working and if you want me to look it over. And then if you really want to go crazy, try to finish the game. Try to finish up the game. But you don't have to do that if you don't want to. The main challenge is just build the logic to change the masks from true to false when they guess a character correctly. Any questions on that? Any questions on that at all? I'll give you guys like another minute or so to roll in any questions. And if there are none, then we'll end today. So tomorrow will be, let's see here, using just what I've learned so far. Wait, can we finish the game without learning any more new stuff using just what we've learned so far? Yes. Yes, you can. 100%. You can 100% finish it up. And I would highly recommend you too. And regardless, there may be things that may or may not make it easier for you to continue. If so, then just Google it. Just Google. This is time for you to explore. That's why they're called challenges, because they're not meant to really be that easy. They're meant to challenge you. They're meant to push you to your limits, but also push you forward. Because regardless of whether you get it right or wrong, you're trying, you're learning things. You're going to either learn a right way to do things, or most likely you're going to learn a couple wrong ways to do things. But regardless, you learned those things. Now you know whether, if you did get it wrong, on what to avoid doing next time. They're all valuable though. Let me see here. What was I going to say? There was something else I thought. Oh, tomorrow. Tomorrow we will finish up version 1 of the game. We'll finish up version 1 of the game. And then we're going to add more stuff to the game. Because, you know, the games we've made so far are cool. Alright, they're cool. Because we made them ourselves. Which makes it cool. But, you know, if I wanted to make this an arcade game, for example, I have no way to save high scores, right? So maybe we should implement some saving functionality. Because what makes a game fun is saving not just high scores, temps, how much you've completed, you know, all those cool little stats. So maybe we should learn next and implement, and maybe the user or the customer will request us to be saving off cool stats. Additionally, maybe the customer doesn't want to program, because customers usually do not want to program at all. That's why they pay you. They pay you to program. So the words they give you, they're not going to touch your Python program, because no. Why me as a customer, why would I want to touch your code? I'm going to give you a list of words, most likely as an Excel sheet or as a text file. That's what customers will do. And it's your job as the developer to read it, all right? That will be the extended thing that we're going to do, our V2 of our product. I guess V2 and V3. Version 2 is going to be us, reading from a file and getting words from a file. So that way we can accept just files from any normal user. Then 2 will be saving our high scores. We'll save them to a file normally as readable text, and then we'll also show how to save them as binary data. Go ahead and ask your question. You don't need to state that you have a question. Are you sure, Kwai? Are you sure you're good? I'm good for now. We'll see if you're good for now, all right? We'll see about that. When you get to the type of lines of code, for example, from 12 to 22. 12 to 22. I guess you also maybe want 23. Can you go just a bit slower when explaining? Just a tiny bit, enough where it would be easier to keep up. Sure. That's why we did the recap. Also, again, this is all being recorded on YouTube, so you can go back and see what it said on YouTube. Additionally, so what I recommend is going back in the video, rewatching what I said earlier, and make comments. If you don't want to do that, then you can subscribe to our Discord Premium or our Patreon in order to get those, get the comments that I'm going to be putting in afterwards, so you can just reference those. The cheapest option would be Discord bit membership. It is more expensive than Patreon, but the Patreon bit one is $1. It does not get you access to the supporter chat. But the Discord one is $3, which is more expensive than Patreon, and it will give you access to the supporter chat. Also, there is a 1-week free trial. So you could start that up and get all of the content we're doing here for free for a week, and see if it's actually worth your time. Any other questions? Ask away, you guys. I'll wait another minute or so. Again, this is here for reference as an alternative to doing it this way. It's up to you whether you want to do it this way or this way. I'm going to keep it like this because I usually prefer doing things this way because it's a little more spelled out and easier to understand. The compressed formats, they can give you efficiencies, but they're sometimes a little bit confusing. All right, I don't see any other questions coming in. So if you guys do have any other questions, make sure you put them into the 100 Days of Rootkit chat. Make sure you put them in there, ask away, and we'll answer them as they come in. All right, sweet. That's all I got for you guys today. I'll see you guys on the next one.